Take two clear solutions in separate test tubes. They look exactly the same: no color, no smell, no label. So, how do you know what's actually inside them? That's where qualitative analysis comes in. Let's go a little deeper. Qualitative analysis is all about identifying substances, not measuring how much is there. It answers a simple question: what is present? Chemists use specific tests to identify ions and gases based on how they react. But wait, here's the twist. You don't need complex machines to do this. Many substances reveal themselves through simple reactions. Add a few drops of a reagent, and a color change appears. Add another chemical, and a precipitate forms. Expose a gas, and it might turn lime water milky or produce a sharp smell. Here's something even more interesting. Different ions behave in predictable ways. Chloride ions form a white precipitate. Copper ions produce a blue color. Ammonia gas has a sharp smell and turns damp red paper blue. These reactions are like chemical fingerprints. Each substance leaves a unique trace. Let's connect this to real life. Testing drinking water, checking air quality, identifying unknown chemicals in labs and industries. All of these rely on qualitative analysis, because before measuring anything, you must know what you're dealing with. Before we wrap up, zoom out for a moment. Qualitative analysis turns invisible substances into visible evidence. It's chemistry's way of asking questions and getting clear answers. And that leads to the next question. If we can identify substances, how do we calculate exactly how much of them is present? That's exactly where we go next.